So today's topic is about Zener diode. So Zener diode is one form of semiconductor device. Semiconductor devices are made up of silicon or germanium, as we all know about it. And most preferably, we use silicon because silica is widely available. Also, it can withstand high temperature and high current capability. So we go for silicon as compared to germanium. And diodes, we have several types of diodes like PN junction, ordinary diode, Schottky diode, Zener diode, light emitting diode, photodiode, laser diode. We have many types of diodes. So under that, today's topic is about Zener diode. So the introduction about the Zener diode. First, we'll start with the introduction. Then we will see what is the symbol, how many terminals it has. Then we will see what is the working principle of the Zener diode, VI characteristics of the Zener diode, and applications of the Zener diode. So the first point of introduction is Zener diode is a special type of diode. So what do you mean by special type? So as compared to the ordinary diode, Zener is heavily doped. And one more special characteristic is it can work in the reverse bias condition. Ordinary diode cannot work in the reverse bias condition. When we raise the voltage, the diode will go into damage. So it cannot maintain the constant voltage. But Zener can maintain constant output voltage irrespective of the input voltage. The input voltage may be fluctuating, input voltage may be changing, its load can also vary, but Zener output will be always constant. Consistently, it is going to maintain constant output voltage. That is the special characteristics and special type of the uh, Zener diode. So second point is it is heavily doped. So that is designed to operate in the reverse direction with a sharp breakdown voltage. The sharp breakdown voltage means that consistently it maintains the constant voltage and it works in the reverse direction. As we have already mentioned in the first point about what do you mean by special type of diode in that case. So third point is when the voltage across the terminal of a Zener diode is reversed. So reversed in the sense is, suppose if it is anode, I'm giving minus potential to this. That is called as the reverse bias. So forward bias is if it is anode. Anode means it is P type. So P and N combination makes the two diode. Formation of the diode, P type. P is anode. And if I give positive supply to this, then that is called as the forward bias. So when the voltage across the terminal of the Zener diode is reversed, and the potential reaches the Zener voltage. So Zener voltage is reached. After that, the junction breaks down and the current flows in the reverse direction. This effect is known as the Zener effect. There will be a constant output voltage. So that is Zener diode. So now the working of a Zener diode. First, we have taken a circuit of an ordinary PN junction diode because ordinary PN junction diode and the Zener diode forward bias working is similar, same to same. So I'm just biasing it with forward biasing. So anode is P type, cathode is N type. P and N type is taken and it is given forward biasing. For both normal diode and Zener diode, the working is same. We know that this is also plus and this is P type. So both will get ripple each other. So any atom, we all know what does an atom consist of. So the center part of the atom is protons and neutrons, and the outer surface is revolving with electrons. And electrons, we have different types of shells. We have K type, L, M, N. The last orbit, the final orbit is called as the valence band. So that valence band of electron has to jump to the conduction band. And we say that whenever there is a movement of electron, there is a flow of current. So flow of current has to take place. The circuit will become like a closed circuit. When this flow of electrons will take place, when it is biased. So when biasing is given, the holes, the plus charge will ripple the holes, will ripple this P type towards the N type. So the valence electrons and the P type will jump to the N type. So there is a movement of electrons and there is a flow of current. So that is the forward bias of normal PN junction diode and normal Zener diode. So now Zener is biased with reverse biasing because Zener is designed to be working in the reverse bias condition. It is a special type of diode which is going to work in the reverse bias condition. Now this is negative, minus, cathode. This is cathode and this side is called as anode. Now cathode is given plus. So we take it this as a reverse bias. So now what is going to happen is when positive is given, here it is N-type. N-type materials are taken here. N-type impurities are doped in that. So this N-type materials will get attracted towards this voltage. So the N-type will move towards this voltage and here P-type is there. The P-type is going to move towards this supply, right? So in between we have the depletion region. In normal diode, what will happen? The depletion region will keep on increase. At one stage, the diode will go for a damage. So, but in Zener diode, the Zener, since it is heavily doped, there is a movement of electron and the electric field intensity is becoming increased. So that is bigger, that is due to heavy doping. So that in that after certain voltage, we say it as a Zener voltage, it makes to make a constant output of that voltage. So we can see from the notes which is given down below. In a Zener diode, yeah, high level impurities are added to the semiconductor material to make it more conductive. Due to the presence of these impurities, the depletion region of the diode becomes very thin. So in this diagram, you can see the depletion region is very narrow and the electric field intensity is very high, right? So now it is reverse biased. P is given minus. So we know that the negatives are getting attracted here. But due to the electrons movement, because it is heavily doped due to some charge carriers movement, this is crossing the depletion region and the depletion region will get breakdown and there will be a flow of current. So that is our Zener diode. So due to the presence of these impurities, the depletion region of the diode becomes very thin. The intensity of electric field, this is important. The electric field is increased across the depletion region due to the heavy doping. So by small voltage applied also, we get a Zener voltage, consistently constant voltage we get. The next paragraph, this shows that when the reverse bias is applied across the diode and when the Zener voltage is equal to that of the supplied voltage, the diode starts conducting in the direction of the reverse bias. The Zener diode voltage is the particular voltage at which the depletion region vanishes completely. That is the Zener breakdown region where the depletion region vanishes completely. There will be some minority charge carriers. Due to that, there will be some leakage current flowing. But after certain point, knee voltage point, there will be a rise of current, sharp increase of current, but the voltage remains to be a constant one. So, that's why we say that irrespective of the input voltage can be keep changed and the load can be also varied, but the Zener voltage will not vary. That is the characteristics of a special type of a Zener diode. As the reverse voltage starts increasing and finally reaches the predetermined breaking voltage, which is represented as VZ, the current starts flowing through the circuit. So at that time, the Zener will act like a series of resistors. So it will not get damaged. It acts like a series of resistors. After the current increases to its maximum limit, after which it remains constant over a wide range of applied voltage as it is a stabilized one. It is also called as a voltage stabilizer. It is a stabilized one. So this paragraph can be seen from this diagram. So what they have said from this diagram is there will be some leakage current flowing, but after certain limit, after it goes for the certain limit, the current sharp increase of current is there, but the Zener voltage is going to be a constant one. That's why it is called as the stabilizer. So Zener is also called as a voltage stabilizer. It's a regulator, stabilizer. So these are all important application of Zener. Those days they used to have filter circuit, RLC circuit to get a constant output voltage as a stabilizer, which was very heavy and bulky and more losses will be there. But after the invention of the Zener diode with a heavily doped region, it is going to be very easy, cheaper with constant output voltage. They're all good invention of our semiconductor devices. So, it's a simple diagram which is showing how the reverse bias is working. So what is the doping here, what is the doping, and how it is going to work. So the very important point is the depletion region is very thin as compared to your PN junction diode. So depletion region is thin, and after certain limit, it is going to maintain a constant voltage. A sharp increase of current is also there, right? So this is VI characteristics of Zener diode. When the breakdown voltage increases, then the Zener breakdown will occur and current will increase immediately and the diode will conduct without damage. The diode is not going to get any damage. So Zener will act like a series of resistor. That will be a protection. So this is the avalanche breakdown, and this is a Zener breakdown region. This region is Zener breakdown region. Avalanche breakdown will occur by the input voltage when the raising of the input voltage. Zener breakdown voltage is like after that voltage there will not be any raise of voltage. A stabilized voltage will be the output voltage. That is Zener voltage. That the current increases. This is any diagram, it has to be shown with x-axis and y-axis. So it is very clear that this is current, I max. This is Zener current in reverse bias. So Zener current increases, but the voltage is going to be remained constant. This is the dotted line which shows the Zener voltage is remained constant in the reverse bias. This is called avalanche breakdown. This breakdown will occur in normal diode as well as in the Zener diode. But Zener breakdown is very important. Zener voltage is very important because after that voltage only we get a constant stabilized voltage when there is a sharp increase in the reverse current. So this is forward characteristics of Zener diode. So the VI characteristics is again explained here. The first quadrant in the graph. This is the first quadrant. This is going to represent the forward characteristics of Zener diode. From the graph, we understand that it is almost identical like a normal PN junction diode. This is the reverse characteristics of Zener diode. So when the reverse voltage is applied to the Zener diode, a small reverse saturation current I0 is also called saturation current. It's also called leakage current. That is due to the some minority charge carriers. So this current is due to thermally generated minority carriers. As the reverse voltage increases at a certain value of reverse voltage, the reverse current increases drastically. This is reverse current. This is reverse current. So this is going to increase. From here, it is going to increase drastically and sharply. This is an indication that the breakdown has occurred, but the diode will not get damaged. In that case, the diode will, in normal diode, it will get damaged because it is not heavily doped. So it will not work in reverse bias condition. But Zener is working in reverse bias condition. So we call this voltage breakdown and Zener voltage, and we call DZ. These are the names could be called for the Zener voltage. Next is application of Zener diode. Anything, whatever we are learning, that where it is applied is very important to remember for lifelong. So this is used as a voltage stabilizer, which is already said. So the fluctuating voltage of the source will be converted to a constant voltage, and that is going to supply to the load. Load may be continuously varying, or source may be varying, source may be increased or decreased, but the output of the Zener is going to be a constant one, stabilized one. So Zener diode is always connected in parallel with the load. So another characteristics what we see, it is always connected parallel to the load, and it maintains the constant voltage. Thus, it is a stabilized voltage. It is used in the meter protection. In multimeters, we are using to control the movement of the meter. So any overload current, so the meter should not get damaged. So that is connected parallel. So it will only give the constant output voltage. You know, when there will be a limit of voltage to the multimeter. More than that, the meter should not get damaged. So in that way, it is protecting the meter. The major amount of current passes through the diode, and in this way, the diode protects the meter from damage. So it is also used as a protection circuit. It is used in a protection circuit. First one, it is used as a stabilizer, voltage regulator, different names we can technically call it. And next is meter protection. It can protect the multimeters where it will not allow to get damaged. It gives only the constant output, limited voltage with its withstand for the multimeter. Next is wave shaping. Sine wave is converted into square wave by using the Zener diode. So it can be converted into square wave. We can connect a single Zener, we can connect back to back the opposite direction, in the opposite direction. So whatever is according to our output need, we can connect the Zener and get a clipping and clamping of the output. So that can be also done. So sine wave can be converted into square wave. Clips can be done. Clipping. This is single Zener clipping, and this is double Zener clipping. Double Zener clip. So this is a small diagram to just show how it is getting clipped. The sine wave, the frequency, this one is getting clipped, and we get only output as a square. So in this way, we can produce different waveforms that can be used for different electronic devices. So that's about the short introductions and the working principle about the Zener. Still, we have more characteristics about the Zener which can be seen in the next class. So this is about only the symbol working of a Zener and its VI characteristics with its applications. So thank you for listening. Have a good day. Thank you.